Vanguard platform infrastructure team. And today I'll be going to do some hands-on with Terraform. So I'll share screen. Okay, so my screen is visible. Can I get a confirmation? Yeah. Okay, so let's just dive into Terraform. So what is Terraform? So if you see on the right hand side, I have a content. So I'd go through like Terraform. I'd go through providers, lifecycle state, some variables, data source, backend modules, some gotchas, add-ons, and why no infrastructure for no Terraform for ITP infrastructure, links, references. So let's get started. So Terraform, like it says, like it's an open source infrastructure as code tool. It was created by HashiCorp, and it's a declarative coding tool. It enables you to use a high level configuration language. They call it HCL, and you use it to describe your desired end state infrastructure. So once you do that, you can generate a plan for reaching that end state, and then you can do an apply to actually provision that infrastructure. Now you can use Terraform to provision infrastructure across multiple cloud. That means you can have it on GCP, AWS, Azure, and you could also use it for like your VMware or vSphere, those sorts of deployments too. So let's talk about providers. So Terraform has this thing, it relies on plugins called providers to interact with the remote systems. So that is responsible for understanding the API interactions and exposing resources. So if you go to the Terraform registry, you will see that there are many public available Terraform providers for various infrastructures. You can have it for AWS, Azure, like I said, VMware, vSphere, Cisco, DNS, GitHub. So we have lots of providers available. In this talk, I'll be focusing on AWS. So let's go back over here. So once we have found a provider, we can use it. We can require it in our configuration, and then we can start provisioning the resources. So like you saw, each of them have their own documentation, and you can go through that. And we must declare which providers we require, and then Terraform will install it, and then we can start using it. So next we have the life cycle of an AWS resource. So what we are going to do is like we are going to use Terraform and we're going to deploy a resource. We are going to update that resource, and finally we're going to destroy the resource. So Terraform has certain commands like to deploy, you can have init, plan, and apply. And to update, you need to run the Terraform plan and apply command. To destroy, you can run the destroy command. So we'll be seeing how these work, and I won't be running the destroy now because we want to see it work. So probably at the end of the talk, we will run it. And here you can see like I have a picture showing all the commands available. This document will be made available to you, so you can go through it and read it on in your free time after the talk. So let's jump to the hands-on. So if you see over here, I have a repository ready. So I have a folder over here called hands-on. Inside that, I have a file called main.tf. So let's start writing some resources. So I'll copy this here. So if you see over here, what I've done is I have copied, I've written the provider. I have told that I'll be using the AWS provider. I have told that please use my default profile. The region will be US West 2 and the version is 3.4. Now one thing to keep in mind, I have done all the installations and the setup ready. There will be a section at the end which will help you do this stuff on your own when you try it out. So currently all this is done for me. So I have already logged into my AWS CLI. So this will just work. So here's the provider configuration. Next, if you see, I have told that I want to deploy a resource. So for this talk, I'll be trying to deploy a DB resource. So I'm going to deploy an RDS instance and I'm going to try to log in from my local machine. So to deploy that DB instance, I need to have a subnet group. So this is an AWS DB subnet group. I have specified that please name it this, and please use these subnets. These subnets are already available. And I'll also tag the resource. I'll tell that this was deployed by me. And once I have this resource, The main,
Pushkar, can I ask you a question?
yeah,
So where is the VPC defined, or is it just the subnet is part of that VPC? It's by default understood.
yeah. So this subnet is part of the VPC.
Okay, you don't have to explicitly say the VPC.
Yeah, no,
Right.
I'm not doing that. So next up, if you see, we have the DB instance over here. So I'm requesting like I want to deploy a resource. It is of type AWS DB instance. Here we have the local name, which I will use to reference this if I want. And you can specify all various parameters. So it's not compulsory to define all parameters over here. So just the important ones I have defined. So like I want a 5 GB storage. I want to use a DBT2 micro instance class. I don't want availability zones, and I want to skip the final snapshot, storage is standard, and other such things. It is a MySQL, the version, name is given, and tags and password. Right now it's hard coded. We'll see how to get away from this one. So if you see over here, the DB subnet group, I have told that I want to use the DB subnet group defined over here. So the way to do that is AWS DB subnet group dot DB subnet group dot the name. So that's what is over here. So this is effectively referencing this. If you see, it got colored. So this will be plugged in over here. So they got related. So let's jump to the terminal. I'll save it. I'm in the folder. So let's run a first command that's init. So what init is doing is like it found that I want to do some AWS deployments because I have the provider over here. So it's downloading a plugin for me. So it's the latest version 3.4. We'll wait for it to download. So yep, Terraform has successfully initialized, and we can start running the other commands. So the next command is Terraform plan. So let's run the plan to see what would get deployed if I ran the apply. So here you can see the plan says that we have 2 resources to add, nothing to change, nothing to destroy. You can see that a DB subnet group will be created. We can check the values. We can ensure that, okay, everything is correct and what we desire. And over here, you can see like all the parameters are there. Some of them are defined by me over here, these. So I just go through this. I check, okay, yep, these are good. And we should be good to deploy this. So once we are happy with this plan, let's go and apply it. Now what the apply will do is like, it will again show me the plan and it will ask me confirmation, like, are you like really sure this will deploy the resource for you? So we need to give the, we need to type yes or no. So once it's done, I will type yes. So again, I check everything is okay. It's looking good. I will type yes. And we have started creating the resource. So now what will happen is this will take a fair amount of time. So I'll just, this takes approximately 5 minutes, I guess. So during that time, let me show you what's happening over here. So if you see, I had only one file over here, but now I have some more files over here. So I have a Terraform folder. If you see, the plugin has been downloaded. So this was the provider plugin. So this is what Terraform is using to interact with AWS. It has all the API libraries defined in there. And we have a state log. And this, if you see, we have a terraform.tf state file. Now, if I open it right now, you can see that it's making an entry for each of the resource being deployed. So right now, it has one for the subnet group. And that's it. Once the DB instance has completed, you will see that another entry has been created under this instances. So let us talk about what this terraform.tf state file is while this is deploying. So I'll just go back to my slide. Okay, so we have the state. So we need that terraform.tf state file to do some mapping to the real world. So Terraform, it requires some sort of database. to map Terraform config to the real world. So real world in this case is the AWS environment itself. So when we define a resource like a resource AWS instance and maybe say foo, then this database is used to know that that particular instance is represented by that resource. Also, we need to have like metadata. So we need to track resource dependencies because to track like which resource to deploy first, because in this case, if you see, we must deploy the DB subnet group first because that is used inside the DB instance. So this sort of metadata is also tracked by this file. And the third is performance. So right now we have only 2 resources deployed, but when you do it for very, very large deployments, so there may be like hundreds of resources. So Terraform must know like what resource already exists and what resource it needs to deploy as part of a change. So if there is a very large configuration, querying every resource to AWS would be very, very slow. And also many cloud providers, they do not provide APIs to like query multiple resources. And they also have API rate limiting. So that is why it keeps a cached state and it treats it as like a record of truth. So if the terraform.tf state file says that I have a record of an AWS DB instance being deployed, then that means that the next time if you add a resource, it will see, I already have a DB instance. The person is adding another instance which is not there. So let me go ahead and deploy this instance. So that is the use of the TF state file. Now, keeping the TF state file locally can have like, you won't be able to work in teams because this is like a really, really important file. If you delete this file or if this file is lost, Terraform has no way of knowing what resource was deployed by you. And unless you have tagging, you will have to go and search for your resource in AWS console. So that would be very painful. So that is why we need to keep this file very, very safe. This is very important for Terraform. And let me go to the RDS console, and if you refresh over here, so you can see it's creating a resource. This is the name. I'll open it. It's creating it, and it has the subnets, the subnet group which I defined, and it is in the VPC. So because these subnets are in this VPC, so it automatically got this info here. So okay, so if you see over here, we have 2 added resources. And if we go back, if we just refresh this, so here we have the endpoint. We could try to connect to this, but that would fail. And you can take my word with that, because if you see over here, the security group rules. So we have a default security group over here. And if you see, only EC2 instances are allowed to connect to this instance. So even if I try to connect right now, this will fail. So the next step, what comes to my mind is like, could we update the resource? Like, could we add a security group rule over here so that we can connect to it from a local machine? So this was like the first part, that is deployment. So let's go ahead and try to do an update. So to update, if I come over here, I have another resource. I'll just copy it over here. So if you see, what I'm doing is I'm defining another resource that I want a security group, and locally reference it with this name. The name of the resource will be P Sharma SG1. It should be in this VPC, and I have tagged it like deployed by me, and I have some ingress rules. So I want my PC to have access to it. So let's go ahead and check my IP. So this is my IP. I'll copy it. I'll paste it here. So I want my PC to be able to access this instance. And obviously, I wanted all outbound traffic enabled. And now once this security group will be deployed, I want to use it for my instance. So to use that, I have this. I will just add it. So if you see over here, this is my DB instance. I will add an entry over here that the AWS security group resource which you have just deployed, please apply it to my DB instance. So this is the way. So AWS security group dot security group dot ID. So the ID for this group will get attached to this instance over here. So now let's do apply once again. Now what Terraform is doing is like, if you see over here, the TF state file, we have uh, an RDS instance over here. They have the attributes, and there's a DB subnet group. So these are two resources available inside this file. Now Terraform found that this particular resource isn't in my TF state file. So it did some diff and it found that I have to change. I have one to add, one to change, and nothing to destroy. So if you see over here, you can see some plus signs over here. So that means this security group will be created. And if you see over here, we have a tilde sign, meaning that the default security group will be deleted and we will get a new security group. No matter apply, because we currently don't know the ID for this security group. So whatever is the ID, it will get applied over here. So let's go ahead and say, yes, please do the change for me. And it is creating the new security group. So I could go over here, I could refresh this page, and we can see we'll see something over here. Okay, it's still creating. Okay, so the security group has been created. It's now modifying my instance. So now let's refresh and we should see it happening in real time. So you can see over here, it's adding a new security group over here for me. It's removing the default one. And once it's done, we'll be able to connect from our instance to this particular DB. So let's wait for this process to complete. Process. Okay, so one is added, one is changed. And just to confirm, if you see over here, if I scroll down, here you can see we have another instance and you can see the egress, ingress. So the security group has also been entered in this DB. So we can call it DB. So it's like it's in JSON format, but yeah, we can say it's Terraform's DB, the local one. Now let's quickly try to connect to prove my point. Just do a new data source. I will see that the host is this. Simple password, change the driver, test function. And you can see over here, so it's connected. So now our DB instance is ready to go. We can fire queries, we can create tables as a whatever we wish. So now back to the tech talk. So obviously I won't run destroy now. I don't want to destroy it currently. So next up is variables and outputs. So like it says, like we use variables to customize our deployments, and the outputs, we can use it to print certain values in the CLI output. And also when using the remote state, we can use the root module outputs. They can be accessed by other configurations via Terraform remote state data. We'll talk about remote state later. And also you can run the Terraform output command to see the specific outputs. So let's come over here, and if you see, I am using like hard-coded values over here, like these. So obviously if you want to use it, you will want to like distribute it to others maybe. You don't want to have hard-coded values. So let's change it so that we can start using some variables. So I'll just copy it. Now Terraform configurations you can write in the same file. you can name it, you can name the file as anything. Let's create a new file so that it remains legible. So paste our variables over here. Also, let's copy the output while we are at it. We'll create a new file, outputs.tf. Now I could have named it anything, but I gave a meaningful name. So now if you see, the way to define variable is simple. You just use the variable keyword, you give it a name, and it can have a type. So type can be like number, string, boolean. You can even have list of numbers. You can have a list of maps. You can even have maps. So if you see over here, I have provided a link. You can go ahead and see what all variables you have. Currently, I'm using just simple variables over here. You can also provide a default value. So I have given default values over here like 5, this, false, multi, and you can see these. So let's change the value. So let's, instead of this, the way to use it, like you can use var dot allocated storage. So now it will pick up from the variables file. So var is the keyword over here. So similarly, var dot instance class, var dot multi-az, var dot skip, and finally var dot storage type. So to just show you like how variables work, I just changed these two variables. Now if you see, let us remove this default value from here. So let us see what happens if you don't provide a default value. Again, I'm going to come back. I'm going to run and apply. So if you see, it's asking me, so please enter a value for this variable. So I could give a 6, I could hit enter, and I could go ahead and change the DB. But if I do the change right now, it will take a lot of time. I don't want to do that. So let's keep it at 5. And then one more thing, if you see, I have the outputs defined over here also. So output is also simple. So you just use the output keyword and a name, local name, and you can define the value. So value is again the same. It's for the same pattern, like AWS DB instance dot DB instance dot ID. So if you see over here, AWS DB instance dot DB instance dot ID, whatever is the ID of this particular resource. You could go ahead and use dot allocated storage or dot instance class. So any of the things, any of the properties or parameters of this DB instance can be output over here. Right now we are outputting the ID, the address, and the port. So let's see if I just run this with this change, what will happen. Obviously the value is same. Terraform detects that we don't need to do any change because allocated storage remains 5. It's doing the diff, refreshing the state. And once it completes, you will see a difference. We will start seeing outputs over here. So here is the outputs. RDS host is this. Now you can use Terraform output command and you can give this name to actually just fetch one particular value. So this is a way to use outputs from one Terraform run. So maybe you have a script, you want to get the output and you want to start, like maybe you have a script, you deployed everything. Now you want to get the endpoint so that you can make a connection. So you can use this in your scripts to do that. So that was variables and outputs. And one more thing. So in variables, if you see, Terraform also supports validation. So you can add validation also. You could read it up later, but to keep it simple, I haven't included it right now. So let's go back over here. So that was variables and outputs. So next up is data source. So we can have many types of data source. So over here, I will talk about external data source, and there's a AWS Secrets Manager secret version data source. So the external data source is used to, like, you can use it to run an external program for you, and the output of that program you can use in your Terraform configuration. So now the only constraint you have is that the external program must follow this protocol. So it must read all the data in the standard input, pass it as JSON object, and it must produce like valid JSON object on standard output. And this will be used to populate the result attribute. and it must print an error if any in the standard error, and etc. So what we will do is, as part of a hands-on, we will use this and we'll try to fetch the user ID from my current machine, and we'll try to use it on a Terraform configuration. So just to show you a demo, so if I run this command, who am I? If you run this command on your system, it will give you the ID of whose system is this. So right now it belongs to me. So it tells the value is P Sharma. So what if I could run this command and use the output in my configuration? So instead of using these, I could change it to use this value instead. So let's do that. And to do that, we have over here this. I'll copy those configurations and I'll paste it somewhere over the top. So if you see, this is a new provider. This is an external data provider. That means like this provider is used to run external programs. We are using the 1.2 version. Now we are telling it that we are declaring an external data provider, which has a local name of user ID, and it will run a program for me. So that program is nothing but it will run a bash script using sh, and it will run this script, and it will take this as input. So if you see over here under the scripts folder, I have the script which you see over here. I'll just open it. So this is a very simple bash script. It takes an input, it does a switch on that, and if it is current date, it will return the current date. If it is the user ID, it will run the whoami command, and it will return the output in this format. So response and this. So this is what is written over here. So you must have it as a JSON object. So that is why we are passing it in this form. So response colon and the actual response. So that is the script. Now, if you see, I'm going to go ahead. Okay, and the next thing over here. So once this runs, the output can be used by referencing this. So data.external.user_id. That's what data external user ID dot result. So this dot result is because we have that is the Terraform thing, and dot response is this one, dot response. So whatever is over here, get me the value for that. So that way you'll get this. Now what I could do is I could use this wherever I am using this. So I could use it over here like this. But I would have to rewrite such a long sentence everywhere. And if this changed, I would have to change everywhere. So instead of that, I have this concept of local variables. So local variables in Terraform can be defined using the locals tag. So you can have it locals and you can say that, okay, user ID will have this particular data. Now I can use user ID everywhere, wherever my name is there. So to access user ID, I'll say local.user ID. So it is not locals.user ID, it's local.user ID. So let me change it here. So I'll say local.user ID. Let's change it here also. Okay, so I have only changed tags for now. You are free to change anything. You can take inputs. You can even run any command. You can use this user ID wherever you feel like. I could even change it over here. So to do that, I could do a dollar. I could use this, and I could say local dot user ID, and it would just work. So it would say this would also remain the same. So P Sharma -1 DB. This is also quite fine. Now I haven't made any change to any other parameters because again, if I do the change, it will take a long time for the update. I have a lot to cover in this demo. So that's why we have changed these. And if you see over here, the password. So it is in clear text. Obviously, this is a very bad practice. You shouldn't be having passwords in clear text in your file. So the good way to do that is to use, you can store your password in secrets manager. So this is AWS secrets manager. I've created a secret over here. So it's this. And if you see over here, the secret value, I could retrieve it for you. Username is admin, password is simple password. So I could write Terraform configuration to fetch the password from the secrets manager. So to do that, I would need the secret ARN. So this is what I would use. And to do that, let me copy this configuration from here. So it's also a data, so I'll paste it here. So now if you see, I'm telling it that we have a AWS Secrets Manager secret version data provider. Local name is DB password, and it is located, its ARN is this. And to start using it, I will have to use this particular command. So let's change our password from this to this. And if you see, we are using JSON decode because if I retrieve the value again, you see this is in the JSON format. So I want to decode this JSON file and I want to get the value at this particular key, that is password. So I need the value for this particular key. So that's why I've done a JSON decode. I'm fetching the value from data.aws secrets manager version.dbpassword.secret string, and I want the value for password keyword. So that is how this will work. Now, again, if you see over here, I have provided links. You can go through and read up more how these functions work and how secrets manager works. So now I think we are good and we can save it. We'll run the apply again. And of course it's asking me for the value because variables still has it. I'll uncomment it so that we don't want to keep on entering. Okay, so yeah, this error is because if you see, we added a new provider over here called external. So we need to reinitialize. So we need to run the init command once again so that Terraform is able to download the files needed to run this particular command, this external. So if you see, downloading plugin for provider external 1.2 version, so it's downloaded. Now we can do an apply. And it is refreshing state for this user ID. So it's running the command for me right now. It's getting the output. And it's also refreshing state for this particular data. So it has got the output for this also. And one thing to ensure is like, it got it because I have the permissions. I have logged in with my credentials and I'm using the default profile. So that is why I was able to get that. It was able to get that password for me because I own it. And if you see, deployed by is being changed to my ID over here. So 3 to change, one change is here, the other change is here, and there's a third change. And if you see, the identifier hasn't changed because it remains P Sharma. That was my ID, which I had picked earlier. So nothing changes over there. And I could show you over here also in the tags, it is Pushkar and it's going to change to P Sharma shortly. It started modifying the resources. It's done it for TP subnet group, the security group. Modifications are complete. We'll wait for it to do it for all the resources. Yep. So it's resource. All have been done. 3 have changed. We could come over here. We could do a refresh, I guess. We should start seeing a change. Yep, it's changed. So it's that simple. And next up is data source done backend. Yep. So now we come back to our main problem statement. So if you see over here, we have the TF state file. Everything is defined over here. Now, what if you told me that, okay, thank you for deploying all these resources for me. Can you give me these files so that I can add maybe another resource, maybe an EC2 instance to it? And I would say, yes, please go ahead, please have this code. But I would have to make sure that you have this TF state file because this is what contains the record of everything I have deployed. So any addition you do would be on top of this. Any removal you would do would be on top of this. So this is a very, very important file. Now, what if you are trying to do a deployment in a team, like where you have like 10, 15 members? At that time, if you make use of this file, two people can simultaneously try to make a change. Maybe one person is trying to change the security group, he's trying to add another rule, while another person he's trying to maybe just modify the existing rule. So now if two people have two copies of the state file and they try to do it, so that will lead to like ambiguous things happening in AWS. So both their local terraforms will think that I have the source of truth. What I have in my record is what is there in AWS. And obviously we'll have race conditions. One of them will succeed. The second person, they will start seeing weird things. Like they wanted to make a change to ingress. Maybe they are seeing another rule coming up. So to prevent all these sorts of issues, we have this concept of like a backend for the remote state. So like it says, when using Terraform in a team, it is important that everyone be working with the same state file so that operations are applied on same remote objects. And with a fully featured state backend, we can use remote locking. Of course, you can have locking so that only one person can run the command at a time and avoid two or more users accidentally running Terraform at the same time. And this will also help keep sensitive information off the disk. So if you see, we had a password field. So right now it's fetching from AWS, so we are good. But had it not been that case, it would have been in clear text in this file. It is still there, you can see. So this is a security issue. You don't want to have your passwords in clear text in a file, that too version controlled. That is a very bad practice. So to get rid of that, we have this concept of backend. So we will be using AWS S3 and a DynamoDB table for a backend. So S3 bucket will store our state file, and the DynamoDB table will be used to have locking so that only one person can run that command. So let me close this. Let's go to the remote backend. And if you see, I just copy this. Let's put it at the top. Now, if you see, we have the Terraform parameter over here. It will have a backend. We are saying that let's have an S3 backend. And for that, we need a bucket. The S3 bucket is this. The DynamoDB table used will be this. And the file name will be the same. You can, of course, change it to TF something, but let's keep it default. The region is US West 2. That is where my bucket is. And if you see over here, let me just quickly show you. So here is my bucket. It's already created for me. I did this beforehand only. There's nothing inside here. And we have a DynamoDB table over here. So this is the log table. It's a very simple table. You can just go ahead and do a create table, and you can simply start using it in your configuration. So now once this is done, I would just go ahead and I will say, Terraform, please reinitialize this for me. Because I'm doing a backend change, I need to reinitialize. You can run the init command to do that for you. Now let's see what happens. So it's initializing the backend for me. It detected that there has been a change. We'll give it a few seconds. So it's acquiring a state lock. And if you see over here, it tells me that you have an existing copy of your state. That means this one over here. Where it went? This. So do you want to copy this over to S3 or you want to start fresh? Of course, I want to copy this over so that I start using the remote backend so that I can share these files with you so that you can build on top of this. So now what it is doing is like it is copying the contents of this file over to S3, and it has got a lock on this particular table, this one, so that any other person is not running the same command at this particular time. So we should be good. If I refresh. So here you can see we have the state file. And it has been successfully initialized. Now, whatever commands I run, it will acquire a lock. It will ensure only one is running at a time. And if you see this file, it's empty. So we don't have any use for this file locally now. Now what I could do is I could check this code into Git, and I could share this repository with you. And if you start working on it, you could just go ahead and you could just maybe change a name over here. Maybe you want to allow major version upgrade. You want to retain your backups. You want deletion protection. You could do this change. You could run and apply over here, and of course you will start seeing those change. And because the tf state file is in S3, so if I later come and try to update the file, I will fetch that information from S3. So that dependency is gone. So this is the use of the backend. Obviously, I won't do this change now. Let's go back. And yep, please don't do it for me now. So if I did know it again, the apply was canceled, it released the state log. So now other people can start using it. So that was for the backend. Now modules. So what are modules? So modules in Terraform they are like a container. You can have multiple resources. So like you saw over here, we have security groups, we have RDS instance, we have subnet groups. And then other modules can call our modules, and we can let these modules resources into our configuration in a concise way. And also we can call it multiple times, either within the same configuration or in separate configuration. So you can have your own modules or you can have third-party modules. So let me show you how you can have your own modules. So if you see over here, this particular hands-on is like a good candidate to become a module, because I have variables defined, I have outputs defined, I have many types of resources, I have 3 or 4 over here. So I could create a separate repo, I could name it tf module db, and I could distribute it to you. Maybe I would tell that if you want to use my module, only thing you need to do is like tell me what are the values for these variables, and the underlying resource will be deployed. You don't need to do anything. So you don't need to write any configuration. All the uh, linking, so this linking with this, and security group linking with this. So everything is done by me. So it's sort of a black box. You can simply start using it. So if you see over here, we have a module defined tf module db. We have one for Terraform for a Vanguard DB. So if you just go to this Vanguard Terraform DB, TF module DB, you'll see that we have this over here. So if you use this module, you'll be able to deploy an RDS instance. You will have security groups, you will have alerts. And let me show you the code locally. So here, if you see, I have cloned it. These are the variables. We have a lot of variables. You can provide values for general variables, security group variables, the alerts, the RDS instance itself. And we want a lot of variables over here because there are lots of customizations. And over here, if you see, this is my actual main file. So we have the Terraform versions defined, what I want. We have some local variables. So the tags, they are common across everything. So we are going to substitute the values for you. We have alerts, SNS topics. We have the security group, ingress. We have 2 ingress rules, 1 egress rule. We have a subnet group, a DB parameter group. It takes a lot of values. And finally, the DB instance. So if you see, all the values over here are variables. So each and everything over here is customizable. So this is one of the modules. Now, suppose you want to use this module, what you would do is, let me come back to my repo. Let me go to this directory, module usage. Let me close this. And if you see, we have one file. To use a module, you use the module keyword. You use, like you say, give it a local name db. And you see the source is at this. So it is in the GitLab and it is at this particular path. So once you say that, you can give the names for all the deployments. So give values for each of the variables. I've given for everyone, everything over here. And yeah, now if I go and if I in the terminal, I could switch to this particular directory. I could say cd /. I'm in the module usage. I would say Terraform init. I would say Terraform apply, and again it would give me all the resources which I want with this. Let me come back. Just to quickly show you some third-party modules. So this is Terraform registry. Of course, if you can create your own modules, you can upload it to the registry, and you can even search. They have the documentation over here. So yep, let's go to the registry. Let's search for maybe Vault. Let's see what we get. Okay. So see, these are third-party some modules. You could click it. So they have the documentation. They tell you how to use it. And of course you could read the documentation, how to, so it's fully documented, well documented, what all variables you need to provide. So that was third-party modules. If I come back and if you see over here, we have 6 to add. So this module will deploy for me the alert topics, the security groups, subnet group, and parameter group. Parameter group, it's a very long one, and the DB instance. So I won't deploy it right now. It will take a lot of time, but that's how it works. Let me close this. Let me come back. So that was modules. Okay, so that was all I had for the hands-on. Now let's talk about some gotchas. So not everything is as simple as it looks. So one of the things is like the changes made outside Terraform, they will not be known to Terraform. And the next update, it will try to undo those changes. So if you see over here, I could go ahead, I could add a tag over here. I could say test value. Now, okay, it's there. So now this has been added, but Terraform doesn't know. So in S3, like in S3, you can see this state doesn't have a record that a new tag has been added. So the next time when you run Terraform apply, it will see that the actual state is that I have a tag, but my own record says that this tag should not be there. So let me go ahead and remove it. So that could be a problem. So if you're using Terraform, you must ensure whatever change you make should be from the Terraform files. You have to run the init plan apply and don't make any change. If you make this sort of change, what you need to do is you need to come in your hands-on main, and over here, let me show you, where is it? So over here, tags, let me say test is equal to value. Now, if I run the Terraform apply command, then it will see, okay, the user is telling me that it has a tag over here. My local state says I don't have a tag, but remote, the actual state says we have the tag. So we should not be making any change. So this is one thing you need to keep in mind. Other thing is protecting the shared state in S3. So we recommend that you have permissions and you have policies defined. So not everyone can access this file, because if this file gets deleted, you are doomed. There is nothing you can do. There's no way you can manage your resources. The only way to manage a resource is to like individually import each of the resource, and that is like super painful. You don't want to go down that path. And some resource creation is not supported, like as in a subscription of type email. And Terraform is still evolving. It has breaking changes, like 0.11 had sorry, 0.12 had some very huge changes. So like they did a complete rewrite in 0.12. So lots of things changed. So you need to keep that in mind. And 0.13 is also out, I think. This code was written with 0.12 in mind. And they have a weird way of handling Boolean cases. So like you may have like a case like, if certain property exists, then deploy this or don't deploy. So they don't have a flag for that. They suggest that you use a count 1 for enable, count is 0 for disable, and that is not intuitive. You could read up more about that. And also we can't use variables in the Terraform block. So as you saw, I'm using variables over here. The main pain point is I cannot use variables in the backend. So now if I have like, I want to use the same file to deploy to multiple regions. So I could have like a bucket for US region, a bucket for Australia region. But the thing is I can't use variables here. I need to use a specific value. So that is like one of the pains of using Terraform. And we have third-party applications or wrappers written on top of Terraform to get across this limitation. And we'll look at those right now. So here are some of the add-ons. We have a TF environment, Terragrant, Atlantis. Let us see TF Envy. So this is a version manager. So because Terraform, you have to run Terraform. The version needs to be specific to that. So if your module is defined on a certain Terraform version, you must run it with that Terraform. So you can use this command. So it's install. So you can install a specific version, and then you can specify. So it's self-explanatory. Won't go deep in that. And Terragrunt is it's a thin wrapper. It provides extra tools built on top of Terraform. So like it says, same things what Terraform provides, but now you can even use dynamic values for your backend. So what I said over here, these can also be made dynamic. Now Terragrunt itself needs to have its own file. We could have a separate session on Terragrunt. So it's a complete new thing on its own. You could check this out. And also once you are in a team and you start to do MRs like merge reviews, you can use this Atlantis. You can open a Terraform pull request. And instead of running the Terraform plan yourself, Atlantis will run it for you. So you just need to write Atlantis apply, and it will do all those stuff for you. So if you can see, you could read up more on that data and line. Next up is like, why no Terraform for ITP infrastructure? So here in Vanguard, we have been using like CloudFormation since inception. And we have lots of battle tested ops scripts. There are Python scripts and there are lots of tests. And switching to Terraform now isn't a trivial task. So if we would have started the work, we would have to support both CloudFormation and Terraform. And it would take a very long time until the migration completes. And we don't even have a clear understanding like what may affect which part. So what I suggest is like, if you are doing some fresh, like you're starting from scratch, Terraform is good to go. You will start learning and building along the way. And so here, I think at Apptio, we have Terraform deployments running with some other team. I will provide links down below. And I could also show a quick CloudFormation demo, like how CloudFormation works, which we use. So CloudFormation has this concept of like stack, a template. It's in a YAML file. Same things, you have parameters. You can have the description type. You could almost see the similarity with the Terraform file. And here you have the resource. You could have a DB instance, give the values. You can use the ref tag to have substitution, like whatever is the value here, please use it here. And you have the outputs. I also have a command to show you quickly how that works. So I could run the mod, manage, deploy. So if you see, we are running AWS CLI command. So it's AWS CloudFormation deploy. Template file is this, is locally available. Stack name. So this is the variable. I passed a name for this stack. And I provided parameter overrides. So DB instance identifier, if you see over here, this will get overridden by this, P Sharma van DB don't keep, and we have some tags. So again, this will also do the same thing for you. Deploy the DB resource. So this is what we are currently doing. Not exactly this, but something similar to this in ITP. Next up, how to try this out yourself. This meeting will be recorded. You can go through it again. You need to have access to AWS. You can contact Help IT if you don't have, or you can contact your manager. He may help you, she may help you. And you need to complete the AWS SSO setup. We have the link over here. You can clone the Terraform Tech Talk repository. So this code is up in a repository. It's named Terraform Tech Talk. You can clone it. You can start playing around with it. You can run this script. This will install everything for you. It will install Terraform for you also. So it's here set up. So it's installing TFENV and Terraform for you. It will do that. And we have 3 folders you can switch to. First one to deploy DB instance. You can switch to the second one and you can run the commands to deploy the S3 bucket and the DynamoDB table. And third one shows you how to use the module. And basic commands you need to run: Terraform init plan apply. And if you want to update any value, you can tweak values, again run plan apply. And of course, once you are done with everything, you can run the Terraform destroy. It will destroy everything. So that I recommend don't leave your instances lying around. It costs us money. So please destroy your instance once you are done. Here are some links and references. It's a link to the Terraform DB module repository I have here. You can take a look. We also have a separate guide specifically for how to use this module. Also, Apptio Kubernetes platform team, they have a very terrific guide written on Terraform. You can go through this. It is simply wonderful. So that's all I had for my session. So I would open it up for Q&A.
If there aren't any questions, I think we can end the talk here. Thank you so much, Pushkar. That was amazing, actually. And please don't use his IP address that he just posted.
There's just one question.
Oh, yeah. All right.
Hey, Pushkar, you at last you mentioned, the cloud formation and the part. So, I mean, the cloud formation scripts will only work on AWS, uh, you know, the infra kind of thing. That would be the difference between the cloud formation and the Terraform scripts, this deployment.
Yeah, correct. So CloudFormation is Amazon specific. It is only for AWS, and GCP might have their own some template. I don't really know, but Terraform, you can use it with GCP. You can use it with Azure. It's simply you need to specify a provider like I showed you. So once you have the provider defined, you can use it. So that's here.
Yep, thanks.
So you could have an Azure over here. See, it's showing Azure. And also you could have a GCP. Is it G? So it's Google. For GCP, I think. You could also have VMware, vSphere. And there are lots and lots of providers. So I have provided the links. You could read it up also. That would be great.
A great presentation, Pushkar.
Thank you.
Awesome job.
Yeah.
At least we can close it here. Thanks everyone for joining. Have a great week.
Thank
Thank
you.
you, everyone.
Thanks, Pushkar.
Everyone.
Thanks, Pushkar. Thanks, everyone.